This lesson is on mid-segments. We'll start with a triangle, and we're going to find the midpoint of each of the sides of the triangle. We could construct it. We could measure it. Less wonderful. We're going to do the cheap and dirty method of just folding the vertices together to find the midpoint. So this will be the midpoint. And since their midpoint divides into two equal or congruent segments, we'll mark them as congruent. We'll go ahead and do that on each of the sides to find the midpoint of each side of the triangle. Just kind of pinch it instead of folding it all the way. It'll make it too big of a mess if you fold it all the way. So find the midpoint of each side. Mark them as congruent, because when we find the midpoint and bisect it, we create two congruent segments. Now choose any two of the midpoints and connect them with a line segment. This line segment is called the mid-segment of the triangle. So the definition of the mid-segment of a triangle is that it is a segment that connects the midpoints of two sides of the triangle. Let's notice a couple of things about the mid-segment. The mid-segment is parallel to the opposite side. We'll prove that later, but for the moment you can just see that it's halfway and halfway. It's always halfway between the top and the bottom. Being halfway between will, of course, make it parallel. Since it's parallel, let's mark it with one arrow. Also, the side that's opposite, mark it with one arrow to show that it's parallel to that one. Go ahead and join the other midpoints to form the other two mid-segments. Each triangle, of course, has three mid-segments. And each of these are parallel to their opposite sides. So go ahead and mark them with arrows to show that they're parallel. Notice something about it. Choose one of your mid-segments. I'll take this one and measure it. Now, as I've got it measured as 12.3 centimeters. Then measure the parallel side, and I come out to be 24.6 centimeters approximately. Measure each one of yours to notice that it's twice as much. It is actually twice as much. Let's write that down on our triangle to make sure that we remember it. So the mid-segment is half of the opposite side. Let's do the same thing again on another identical triangle. We'll fold it half in two and pinch it. We're going to make this time just the inside triangle, and we're going to see another way to show the relationship of the mid-segment and the side. So I'm now recreating the triangle in the middle on a separate identical triangle. I'll draw the triangle. I don't, at this point, need to make all the markings. Having done that, I'm going to cut out the middle triangle. And I'll notice that it is composed of 4 triangles. And conveniently, these 4 triangles are congruent to the original triangle. We can stack them all up, see that they're the same. Each one, there we go. Notice that they're also similar to the large triangle. So here's the small triangles. That angle of the small is the same as the angle of the big. That angle of the small is the same as the angle of the big. This angle of the small is the same as the angle of the big. So the triangles are the same shape. They are similar. Same shape, different size. Can now take the ones I've cut out and notice here's the midsegment. Color it so you can see it. This edge is the same as the midsegment of the triangle. I can move it down to the opposite parallel side and see that it is in fact twice as long. The opposite parallel side to the midsegment is parallel and it is twice the length of the midsegment. That is our midsegment theorem, which is shown here. The midsegment of a triangle is parallel to the opposite side and half as long. How we would do a coordinate proof of this. A coordinate proof is a demonstration using 2 different aspects of a particular circumstance and showing arithmetically or algebraically that they are the same. So the circumstances here that we would have would be given that DE is the midsegment of the triangle, and we want to prove that they're parallel and that it's half. How would we do that? When we place a figure on the coordinate plane to be able to attempt a coordinate proof, what we'll do is the easiest is to put one of the vertices at the origin. You can do it any place, it'll still work. But after you do it a little bit, you'll get a sense of to which one would be the easiest to do it. Here, this one is placed at the origin, and the rest of it is in the first quadrant. Generally, most folks prefer to work in the first quadrant, although it will work in any quadrant. Then please read through the proofs here. First, we use the midpoint formula to find the coordinates of the midpoint. Then we find out that the slope is 0 for this particular midsegment. We also know that it's 0 for the other side because of the way we've placed it onto the coordinate plane. Then to prove the side, we find the length of the two, the side of the triangle and the midsegment, and find out that it is exactly half. By using our coordinates and simplifying it, we find out that the length of the midsegment is p, whereas the length of the opposite side is 2p, or twice as much. A couple of applications of the midsegment theorem. This relationship, we can see that the midsegment is half of the opposite side, so is 13. Here, the midsegment is 5, the opposite side x is double, so it's 10. Coming down here to the veggies, work through these and kind of see which ones will work. Which ones are parallel to JK? Well, YZ. To JL, XZ. Parallel to XY, the midsegment KL, and so on. And we see the sides that are equal. Here, another fun thing to go through is this repeating pattern. Trying to figure out the perimeter of the triangle in different circumstances. This is a fun step. Give it a little try and see how you do.